Is how to calculate frequency or wavelength using the speed of light. Right. So the relationship when we look at electromagnetic radiation, the relationship is the speed of light, which is c, is equal to lambda times nu. Lambda is the wavelength, and nu is the symbol for frequency. Okay. Now, if the problem normally you assume that the problem is talking about the speed of light in a vacuum, so you use 3.00 times 10 to the ninth meters per second. If it's not, it usually will specify that it's in water or it's in air or something like that, and they will have to give you the speed of light, or you have to look that up. All right. So let's look at some example problems. So here we're looking for the frequency. They give us the radiation. Okay. So we know that the speed of light is equal to the wavelength times frequency. If you use the formula triangle, you can put it in the triangle like this. Since we're solving for frequency, that's going to be the Greek letter nu. And so we write our equation. Nu is equal to the speed of light divided by the wavelength. Okay, then we're going to plug our numbers in. 3.00 times 10 to the 8th meters divided by seconds, meters per second. So we're going to put the seconds on the bottom of our fraction. Okay. One easy thing to do, anytime you have units that are per units, like meters per second, you put the per unit opposite of the number. All right. So then we want to put the wavelength on the bottom. So 495 nanometers goes on the bottom. You'll notice meters and nanometers are not the same unit, so that's not going to cancel out. So we have to add one more step to it. We have to convert the nanometers to meters. So we're going to use the relationship 1 meter is equal to 10 to the ninth nanometers. There's a billion nanometers in a meter. So 10 to the ninth nanometers goes on top. Because nanometers is on the bottom, we have to put nanometers on top so it'll cancel out. We put our 1 meter on the bottom. You'll notice our meters will cancel out. Our nanometers will cancel out. And we're left with seconds on the bottom. Now, seconds on the bottom means it's 1 over a second. Okay? So we plug that in our calculator. It's going to be 3.00 times 10 to the 8th divided by 495. Get your answer, then take that answer and multiply it by 10 to the ninth. Or you can take everything on the top, multiply it together, take everything on the bottom, multiply it together, and take the top and divide it by the bottom. All right, when we do that, we get 6.06 06, and it looks like it's repeating. Okay, and then times 10 to the 14th. Okay, so our units are 1 over a second because we had seconds left on the bottom. 1 over a second, or basically that's 1 cycle per second, what that is usually referred to. That's going to be hertz. Okay, our wavelength had 3 sig figs. Our speed of light has 3 sig figs in it, so that means our answer is going to be good to 3 significant figures. So it's 6.06 times 10 to the 14th hertz. Okay, now, if we had to look up what type of electromagnetic radiation it is, we have to go to our electromagnetic spectrum. The easiest way to do it here on this one is to go with the wavelength. We find 495. We're going to find it's going to be blue visible light. Okay. Let's look at our next example. Here we're looking for the wavelength. Okay, so wavelength is going to be equal to the speed of light divided by the frequency. We'll plug our numbers in. 3.00 times 10 to the 8th meters divided by seconds. So we're going to put seconds on the bottom. Okay, and then since we're dividing by frequency, we're going to put that on the bottom, 6.41 or 6.45 times 10 to the ninth hertz. Now, hertz is equal to 1 over a second. Okay, and so that's an inverse second. So instead of putting that, second, 1 over second on the bottom, that second's going to kick up to the top. Okay, and so we're putting the 1 down here. We're not going to write it, but the 1 goes down here and the second goes on the top. Okay, anytime you have a fractional unit, the top unit goes with the number, the bottom unit goes opposite of the number. So it's going to kick up to the top. Right? So our second's going to cancel out. The problem doesn't specify what distance or what length measure or what length unit we need it in. So we're just going to go with meters. We plug that in our calculator, and we get 0.0465 116. Okay, some other numbers, so we'll put dot 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 meters. Okay, so both of these are good to 3 sig figs. So our answer is going to be good to 3 sig figs. Remember, leading zeros never count as significant figures. So 0.00465 meters. All right, to look up what electromagnetic radiation it is, this one, if we try to go with, we could go with the wavelength, or we can go with the frequency. The frequency is about right here. That's going to put it in the microwave range. Okay, so that's a microwave radiation. Look at example number 3. Another one we're looking for the wavelength, but this time we want it in nanometers. So we have to add one more step to the end of it. So our wavelength is equal to the speed of light divided by the frequency. So we plug in our numbers. Speed of light is always going to be 3 times 10 to the 8th meters per second, unless the problem specifies otherwise. Okay. We're going to divide by our frequency, so that goes on the bottom, 5.099 times 10 to the 14th hertz, which is 1 over a second. Okay, so we'll put the 1 there, and a second kicks up to the top. Our seconds will cancel out. We stop there, we're in meters, but we want nanometers. So 1 meter goes on the bottom, so that meters will cancel out, and our 10 to the 9th nanometers goes on the top. All right, so we plug that in our calculator. We're going to get 588.350 and a bunch of other numbers. Okay, and that's going to be, I won't cancel out our meters. We're going to be left with units of nanometers. So our speed of light is only good to 3 sig figs. That 10 to the 9th, that's an exact number, so it has an infinite number of sig figs. This one, our frequency, has 4 sig figs. So we go with the least number of sig figs when we multiply and divide, so it's going to be 588 nanometers. Okay, to see what kind of radiation that is, we go over, since it's in the visible range, okay, we're going to go over here. Here's 600, there's 550, so that's about 575. So somewhere around here, it's going to be green visible light. Okay, so that's how you use the speed of light equation to solve for wavelength or frequency.